Okay, so looking at those measures of center and spread and the shape of distribution, we just discussed how the data distribution can have various shapes. Okay, we saw that one of them was evenly distributed. We saw that one had a mound in the center, and we saw that there is data that can have mounds to the left or right of the center. Okay, so first of all, a uniform shape is basically level. So like the first example we saw, that was the, what was it? The birth month. And we'll just relate it back to that example, okay? So in that number line, we had our data items. Just going to draw something here, right? And we look at it in the sense that we can draw a straight line or sort of a straight line above the data. The next shape is considered to be a normal shape. A normal shape has a mound in the middle with the symmetric tails at each end. In our example, in the first Explorer, this one was the birth weight that gave us this kind of shape. And finally, we have a skewed distribution. Okay, a skewed distribution has one tail and is much longer than the, or one tail is much longer than the other, right? Now, in this case, you have to look at where your mound is at. The outlier data is what creates our tail, and this is the direction in which we say the data is skewed. So in this example, tails to the left, that means it is skewed left. In this example, we have our mound to the left, outlier to the right, which means our data is skewed right. Okay, now shape is only one way of characterizing a data distribution. Another way is by identifying the distribution's center and spread. Okay, so let's go ahead and look at what these are. Our center values, we use the mean of n data values, which is the sum of the data values divided by n. And we know that in order to find these values, that should be an equal sign, we would take our first data item, add the second data item, add the third data item, and so on and so forth, according to however many data items there are, and divide by that total number of data items. Okay, now the X bar, this here, if you saw the calculator tutorial, you're familiar with the sample or symbol, sorry. The X bar represents the sample mean. And this is what we use 100% of the time when we talk about mean, okay? These are the values, or this is what we will be using the most. Keep in mind these symbols. We have the X bar. Now, this next symbol is the Greek letter mu, okay? All this represents is the population mean. We do not use the population mean in this class. We stick to the sample mean, okay? Now, standard deviation of n data values gives us the average distance of a data value is from the mean. Now, as you can see from the formula, this is a very complex formula. I do not have you do this by hand simply because we have calculators, we have the tools to input this and achieve this in a matter of minutes, 2 to 3 minutes, right? Instead of spending 30 minutes finding one value. So looking at this, the capital S represents the sample standard deviation. And sigma, this little O down here, this Greek letter sigma, represents our population standard deviation. Okay, now as opposed to the center measure of the mean, for standard deviation, we use the sigma symbol. Okay, so in your calculators, both of these values are given to you, both the S standard deviation and the sigma standard deviation. We are going to be focusing on using the sigma as our value for standard deviation. Now, for the median of n data values is, as we know, the middle value when the data values are written in ascending order, right, from smallest to largest. And IQR is the difference between the median of the upper half of the data, which is our third quartile, and the median of the lower half of the data, which is the first quartile. Okay, the only time I believe you have seen quartiles in the past is when you have worked with box and whisker plots, which we will be doing. So IQR is found by taking the third quartile and subtracting the first quartile. Now, in this example, we are going to find the measures of center and spread for the distribution of baby weights and the distribution of the mother's ages. I'm going to go ahead and do the baby weights and walk you guys through this. Okay, so we are looking at this data here, baby weights, the center column here. Okay, if you have to write them down or if you need to hit the pause button to enter them into your calculators, go ahead and do that. All right, so once you get to your calculator, remember you hit the stat button. Oops, wrong one. Stat, edit, and it takes us to our table. Now, as you can see, I have already input my data items, starting with a baby weight of 3.3, all the way down to the 20th item, which is 3.5. Okay, in order to find our data values, we hit stat again, calculate, one variable statistics. I hit enter, and you can see all of my statistical measures listed for me here. So first of all, we're being asked to find the mean. Zoom in here. Okay, remember the X bar is the mean. So looking at my calculator, the mean shows to be 3.5. Now, don't forget the unit of measure. We are talking about weight in kilograms. Okay. Second thing we're being asked for is the median. So I'm going to come back to my calculator. Median is down here, okay, where it says MED. So MED is 3.5, the median is 3.5. Once again, kilograms because we are talking about weight. Now, this should not be a capital S. Remember, we do use sigma for standard deviation. And if I come over this way to my calculator, you can see that the standard deviation is 0.14491. Well, I'm going to go ahead and round it to the tenths place. So we're going to say it is 0.1 kilograms. And finally, for the IQR, remember the IQR is taken by subtracting the third quartile and the first quartile. Going back to my calculator, I see that quartile 3 is 3.6. And quartile 1 is 3.4. So if we subtract those two values, 3.6 minus 3.4 gives us a total of 0.2 kilograms. Okay, now you guys already saw how I did that in the calculator. I want you guys to practice with your graphing calculators. So go ahead and flip back to the data. Oops, wrong page. Flip back to the data of mother's ages. So this is the column you're looking at. Okay, if you need to hit the pause button now to enter that data, go ahead and hit the pause button now. Here's the data you need. And then go back and fill in the information for your notes. Find the mean, median, standard deviation, and IQR of this data. Okay, this is the data you should have for the mother's ages. If you do not have this exact value, please go back and check your data measures. And what I mean by that is go back to your calculator, check what you entered into the table because you can very easily make mistakes when you are entering so many data points. It could be that you just missed one item or you typed it in incorrectly. Okay,